This short video is intended to help you get started on the identity puzzle. I really like this activity because now that we've spent a few days learning how to simplify identities, you're starting to kind of get the idea. The problems that you have on this paper, they're perfect. They're the perfect next step for you to keep growing and understanding and basically realize what does it take to simplify identities. Now I'm going to do, I think, 5 or 6 problems. They're intended to kind of get you a little jump start, and let's begin. I believe this problem is in the first column. Do you see it? It's about halfway down. Negative cosecant sine over secant. Now, you've seen me do this a couple times, and it's actually a pretty popular strategy. That is, when you have these reciprocal identities like cosecant, to say that, hey, I'm going to change that. I'm going to flip it so that it turns into its reciprocal. And the same thing here with secant, we're going to flip that. Now, you'll notice that I'm not flipping the sign because, well, typically we like to keep functions. We like to keep sine functions. It's only the ones that are reciprocals that we change. Now, this red secant is going to flip up and it's going to change to a cosine. So that's nice. And then that blue cosecant, that's going to flip down and that's going to turn into a sine. So now I have everything looking like sines and cosines. And often when that happens, you're able to cause things to cancel, to simplify, and that's exactly what happens here. We're actually still left with the negative sign. Nothing really happened with that. And we're left with that red cosine for a final answer of negative cosine. How about this problem? I believe it's in the second column. It's the second one down. Now, the reason I'm going over this is because you're going to find out that it gets us starting to think about how to do common denominators. I haven't actually showed you much with common denominators, and so let's take a look at what it takes to subtract. Now, you see what's happening here? We're subtracting a fraction with a non-fraction. And, well, whenever you subtract a fraction with a non-fraction, you're going to need both of them to look like fractions. And so this is why we need a common denominator. Now, the only denominator I have right now is this sign. So that means that I'm going to need to put a sign in this denominator. But can I just put it there? Well, yeah, as long as I also multiply the top by sine. So what's happening here is we're basically saying that we need a sign. I'm going to put it there, but that means I have to multiply the top and bottom by sine. Now, look what happens particularly when you multiply the top by sine. Yes, you get a sine squared. So when I multiply the top by sine, I actually get another sine. Again, that gives me a sine squared. Now, I still have this 1 over sine. Of course, it was a fraction to begin with. So now I can subtract my fractions. Now, when you subtract fractions, you just subtract the numerators. You leave that common denominator the same. You leave it alone. You don't have 2 signs in the denominator. Again, I only have 1 common denominator. Now, why did we do this? Well, again, it was the only way that I could actually subtract, that is to have a common denominator, and it gives me something kind of special here in the numerator, 1 minus sine squared. Have you heard about that before? 1 minus sine squared. Well, if you look in the little identity book, and I want you to get familiar with this, 1 minus sine squared is the same as cosine squared. So I change my numerator to cosine squared. Now the whole problem is in terms of sines and cosines, and we're on our way to a final answer. Now, there's another little trick in this problem. You want to recognize that cosine squared that I circled in blue, well, that cosine squared can be rewritten as a separate or as 2 separate cosines, of course, that are multiplied together. Now, when I write that as 2 separate cosines, it allows me to see a special cosine over sine that is coming from at least part of that fraction. And now cosine over sine that I put a box around, that's the same as cotangent. Of course, I'm still left with this cosine. It doesn't change. And so now I have cotangent times cosine. So, common denominators. It was the only way to start this problem since I was subtracting fractions. And once I multiplied the top and bottom by this sign, then I was able to get that sign squared and eventually subtract those fractions, leaving me with a cosine that could turn into, at least one of them could turn into cosine over sine, leaving you with cotangent. Let's look at another one. I'm still in the second column. I believe I'm about halfway down in the second column. This problem can look a little bit more overwhelming, but if we just kind of relax a little bit, we see that there is one of these reciprocal functions. I've shown you that flipping a reciprocal function is a really handy way to be able to turn it into something a little more familiar. So I can turn that secant, I can flip it down and turn it into a cosine. Now, what this does is it helps me see that, well, that I'm now adding, of course, a fraction with a non-fraction, but never fear, that means I just need another common denominator. Now, the denominator currently is a cosine, so that means I'm going to need to put a cosine in this denominator. Of course, you also have to put it in the numerator. Now, are you guys okay with me just saying that that would be the same as getting another cosine up in the top, which ultimately is going to be a cosine squared? So I didn't show multiplying by cosine. Instead, I just said that, hey, that's going to give us a cosine squared in the top. Now, what we're ready to do is we're ready to add the numerators. You add the numerators, you leave the denominator common, so that means that it's just a cosine in the bottom. Hey, look at that numerator, sine squared plus cosine squared. Well, that's what started this whole thing about a week ago. Sine squared plus cosine squared, of course, that is equal to 1. And suddenly I have 1 over cosine, which by identities is actually the same as secant. Another look at a common denominator, basically multiplying the top and bottom by a cosine, eventually giving me sine squared plus cosine squared, which turned into 1 over cosine, which is secant. I want to show you 2 more. This one is in the last column. You see it there? It's the second one in the last column. Now, at first glance, this kind of just looks pretty nice, tangent plus cotangent. But if I change this so that they're both fractions, I'll be able to write these as sine over cosine plus cosine over sine. Okay, now that they're both fractions, we're going to be able to use common denominators to be able to add them together. Now, what's missing from each denominator is what's going to make it common. So this fraction right here is missing the sign, and that means that I'm going to need to put a sign in this denominator. Of course, that means you also have to put it in the numerator. And then what's missing from the other denominator is a cosine. So that means I'm going to have to put that in the numerator. Excuse me, I'm going to have to put that in the numerator and denominator. So what you see here is an example where I actually need to put what is missing into both denominators. And what's missing is the other denominator. And so now we have common denominators. Of course, the common denominator is sine, cosine. Again, I only have to write that one time. And look at both those numerators, sine squared and a cosine squared. It kind of looks like the other problem, leaving us with 1 over sine cosine. Now the cool thing here is that both of these, because it's 1 over, can be flipped up to the top. Both of them can be flipped up to the top, which would change each of these into the reciprocal function. In other words, I can think of both of these as 1 over sine, and I can think of this as 1 over cosine. And both of those change to be their reciprocal. Of course, a secant and, a cosecant and a secant. All right, so you've seen quite a few examples of common denominators. Let's do one problem that kind of takes us back to something I showed you a few days ago. Now, I believe this problem, where is this? It is back in the second column. It's the last problem there in the second column. Now, I just don't want you to forget that you have other strategies, not just common denominators. Here we have a strategy that recognizes a repeated function. When you have a repeated function, then it's factoring. It's factoring that's required. Remember how we did that? You're just going to factor out that repeated function. So I'm going to factor out a cotangent. And, well, when you factor, it's kind of like reverse distributive property. You want to be careful that the first one, that you aren't left with nothing, you're actually left with the number 1. And, of course, in the second half of that binomial, I'm left with a cosine squared. So we factored out that repeated cotangent. Now, why did we do that? Well, typically you get something special that can be changed. Here's this 1 minus cosine squared. Remember, that can be changed into a sine squared. Looking at your identity book, I still have this cotangent. I wonder if somehow that cotangent is going to be able to interact with that sine squared. It should, because I'm going to change it to be cosine over sine. Remember, that's the quotient identity. And now we have the ability to be able to cancel the sign in the denominator with one of the signs that's in the numerator. So that's going to leave us with a cosine and just a regular sine. In other words, cosine times sine. So don't forget about some of the strategies that we did earlier. In this case, just a gentle reminder that we can use factoring. Now, the rest of the problems are ready for you to simplify. You can color in the little puzzle with each of the shaded regions. You're not going to get a real awesome picture, but it is going to have some type of symmetry and sort of nice look to it, and that can be a way that can help you to check your answers.